Welcome student, in this video we will see the synchronous or clocked sequential circuit. The synchronous or clocked sequential circuits are represented by the two models. First one is Murray circuit and Mealy circuit. The Murray circuit is nothing but, in this model the output depends only on the present state of the flip-flop. The output is depends upon only present state. In case of Mealy circuit, in this model the output depends on both the present state of the flip-flop and the input and also the inputs, right. So, the output depends upon inputs as well as present state. So, in both the model we have the state diagram and state table. So, the state diagram is nothing but pictorial representation of the relationship between present state, input, next state and output. So, it will give the pictorial representation between the input, output, present state and the next state. Similarly, we have state table also available, right. So, in this circuit we are going to discuss about the Murray circuit, right. Now, we will go to the state diagram. So, this is the Murray circuit, the state diagram is given. So, there are 4 states available, A, B, C, D, A, B, C, D, 4 states are available, is given by the circle. So, inside the number is available, this is nothing but output, only one output, whatever may be the input, there is only one output, 0 for A 0, B also 0, C 1 and D is 0. So, that is indicated by the state table also, for A 0, B 0, C 1 and D also 0, right. So, this is the present state and output. This output is given by the circle. Inside the circle we have one binary number available, that is nothing but the output. So, this is nothing but input. So, input it has two types, x equal to input may be 0 or 1, right. I already know that Murray circuit depends upon only the present state, present output is depends upon only the present state, not depends upon the input. So, that we are getting the output, the constant output for either x equal to 0 or x equal to 1, not depends upon input, right. So, only it is depends upon the present state, right. Now, we will see the how it is changes, right. First we will take the state A, right. When x equal to 0, this is nothing but input, this is output. When x equal to 0, A goes to A itself, right. For that output is 0. So, x equal to 0 mean A goes to A itself, output is 0. Suppose input is 1, x equal to 1 mean A goes to B, right. So, A goes to B when x equal to 1, for that also the output is 0, right. So, A goes to A when x equal to 0, A goes to B when x equal to 1, in both the case the output is 0, that is given here, right. Input 0 means A goes to A itself, input 1 means A goes to B, right. Now, we will see the next state, we will take the B. Suppose x equal to 0 means B goes to B itself, x equal to 1 mean B goes to C, in both the cases the output is 0, right. B goes to B when x equal to 0, B goes to C when x equal to 1, both the case the output is 0, right. So, that is indicated here. Now, we will go to the third state, C. When C x equal to 1, it goes to C itself. When x equal to 0, C goes to D, right. C goes to D when x equal to 0. C goes to C itself when x equal to 1, right. C goes to C itself when x equal to 1, C goes to D when x equal to 0, both the case the output is 1, right. So, that is the third stage. We will go to the fourth state, D. What will happen? If x equal to 1, D goes to D itself, see this, when x equal to 1, D goes to D itself. When x equal to 0, D goes to A, right. When x equal to 0, D goes to A, right. D goes to A when x equal to 0. So, this is the circuit developed by the Murray, the state diagram, the corresponding state table also available, right. So, there are 4 states available, A, B, C, D, indicated by the circle. Inside is given as output. The output depends upon only the present state, not depends upon the input. So, whatever may be the input, we are getting the same output, 0, whatever may be the input, right. So, that we are getting the only one output. So, this number indicates the input, right? So A goes to A itself when x equal to 0. A goes to B when x equal to 1. Both the case the output is 0, right? So this is the state diagram. Now we'll see the description. What is the description given for this state diagram? The director lines are labeled with only one binary number representing the input, right? The director lines are labeled. From A to B, one line is there, in that one binary number is available that indicates the input. The output is indicated within the circle below the present state, right? There are 4 present state A, B, C, D. Below that one binary number is available. So that is nothing but output. Output is indicated within the circle below the present state, right? The NS is nothing but next state of the flip-flop after the application of clock pulse, right? We have present state, the next state, NS mean next state, right? So in this video we discuss about the state diagram and state table of the Moore circuit. Thank you for listening.